made a mistake there. That is no question there. Epsilon x was equal to what? I wrote it on the board for you. Yes or no? All you have to do, read the question here, which some people didn't do it correctly. They do odd things with these numbers. So sigma x is how much? Sigma x is, look at the unit, is 5 KSI. Sigma y is what? Sigma y is minus 3.5 KSI. One is compression, one is even people don't notice the pluses and minuses, the type of stress, which is lecture 1, ME 218, uniformly distributed along the edges. That's the sigma x and sigma y. Okay, putting that in that equation is not a big deal. You have to follow the sign. So you will do that, and after you get correctly done, this becomes 204 micro. Now, how many times did I tell you in this class and the other class to express your epsilon in micro? Again, some people write 10 to the minus 4, some people write 10 to the minus 5. Worst thing, some people write epsilon x in 10 to the power of minus 4, then epsilon 5 in 10 to the minus 5, and this one 10 to the power minus 4. Again, the unit of strain is micro. Is that simple enough? So anyhow, that I do not subtract point, but I don't like it when people do that because they have not listened carefully. They didn't see what is in the book, etc., etc. Anyhow, this is epsilon x. That is epsilon y. Again, you have to carry the sign there, which everybody can do with no difficulty. And epsilon z, which is because this plate is being stretched and compressed. Therefore, the third dimension is going to change. And that becomes minus 16. So really for this part, I should give you only 1 or 2 points. But nevertheless, I gave you 5 points because I didn't want to subtract any point, more point from you. Then that's not the question. That's the amount of a strain. A strain is the unit amount of deformation per unit of length. Therefore, you want to calculate the delta. Delta equal to epsilon times L, which is delta along the x direction is equal to, of course, 204 times 10 to the power of minus 6 times 5 inches it was. So it becomes 1.02 times 10 to the power of minus 3 inch, etc., etc. So as you see, we can calculate. This is the question. This is not the question. This is the question you should answer. Delta y also become minus 170 times 10 to the power of minus 6 times 3 inches equal to minus 0.510, 3-digit, times 10 to the power of minus 3, etc., etc. And delta thickness or delta z or delta thickness, well, however you want to call it, that's up to you, because the thickness of the plate is changing, and that is minus 16 times 10 to the power of minus, 10 to the power of minus 6 times 1/2 inch, and that become equal to minus, we can write it minus 8 times 10 to the power of minus 6 inch. I ask you always to use 10 to the power of 3 and 6 just for simplicity, and you do less error anyway. So this part I gave you 10 points is really throw-in number. To me, that was, everybody should have been able to do that. But not understanding the difference between epsilon and delta was a big deal for me. Is that understood? Yes or no? Then part 2. Now coming to part 2 is very interesting. So this, there is no gamma here. Is that correct or not? There is no tau, there is no gamma. Yes or no? Therefore, epsilon x and epsilon y are the principal strain. Already you have the principal. Some people went and calculate. I don't know what they did. So that means there is a misunderstanding somewhere that they should have been able to correct it through the other homework or other quizzes. Now, I'm not saying that everybody should be perfect. No, you are in class, you are bound to mistake. But this mistake particularly should have been addressed before. Everybody understand what I'm saying? That therefore, as you see, tau is equal to 0. There was no tau was given. As the result, gamma, this is part B now. Gamma is also equal to 0. Therefore, if gamma is 0, this must be principal strain. Yes or no? So principal strain happened to be like that. So therefore, you draw your circle. Of course, I don't know what happened. Oh, yeah, here it is. Yeah. Here you draw your circle. This is epsilon. Yours was simpler because this was 204. So that is the x or plane perpendicular to the x. And the other one was minus 170. So that is y. For the other class, the problem I gave them, this was x, this was y, which was a little different. And here for you was simpler. That was x and y. Naturally, the center of the circle, you add these two divided by 2, and that becomes the radius. This becomes 17. This becomes 17, which is the location of the C, and the radius becomes 187. 187 and 17 become 204. So that is not the point. The point here, I am not asking for principal strain, okay? I am not asking for principal stress because it's already given to you. That's the whole point. Is I'm asking you now change that into what? Go from xy to x prime and y prime. This was your x and y direction according to the, now you are going in the direction of the world. Is that correct or not? That direction of the world define x prime axis and y prime axis. Many people did it correctly, unfortunately. So this is x prime and that is y prime. So you go here theta, as first of all theta is counterclockwise. It is not clockwise, so it's counterclockwise. You calculate that, the geometry is given. Theta equal to tangent minus 1 of 3 over 5, 3 inch over 5 inch. Okay. Now, for some people, couple of people, for peculiar reason, they call this way x and this one y. Everybody understand that? I don't know why. What they did, I don't know the reason. But then if you do that, this transformation is not over the x. This transformation is over the y. Everybody understand what I'm saying? So it will be the same thing. You have to be careful in your final result because they use the rest of the problem, they use it as this is x, this is y. For them, this is x, this is y. Everybody understand what I'm saying that because they changed the direction 90 degrees. Nevertheless, couple of people, I think they made a mistake, but they can check it themselves what they did. Anyhow, for this one, I have to get the x and I have to go 2 theta. 2 theta, that angle become how much? You 31 degree. So that's 31 degree. So 2 theta become 62 degree, and most importantly must be in the same direction, which is the counterclockwise direction. So you go to there, you find x prime and y prime. Now the next question, which is important, is okay, gamma over 2 is equal to radius. Is that correct or not? Yeah, this is the largest. First of all, we are not out of plane. We are in the plane, so we don't want the other one. I want along the shear. If along the world, I'm not out of plane. I am in plane. So some of you went, again, not knowing what you are doing, you draw the other 2 circles. Well, I'm not asking for out of the plane. I'm asking for in plane. This is this action. You see, this is the whole understanding of the system, guys. If you are going from here to here, which rotation is this? This is the rotation about the z-axis, yes or no? So therefore, you are in plane. That's all you need. You don't need any other circle. Is that correct or not? Yes? So therefore, you are going from x to x prime. You are not turning it this way. Everybody anyhow. So that is 2 theta, or this is 62 degree. Now here is the next question. So do I need, this is my gamma x prime, y prime. This is my gamma x prime, y prime. One of them is plus, one of them is, what is this? Now, what's the sign of that one? Minus. If you didn't answer, you lost point there. Everybody understand what I'm saying that? Because you just put the magnitude there. Because this, again, this is going like that. This represents on the x prime, this is like that. If this is x prime, this is y prime direction. On the x prime is positive, means like that, going with the arrow. Many of you didn't arrow. With the y prime is negative, so you should go against arrow. If you do that, as far as your tau is concerned, is this plus or minus? This is a minus scenario. So many of you got it correctly, many of you said they didn't. So many of you even didn't address it. Anyhow, that's the reason. Some of you missed the 2 because you forgot to put here gamma over 2, or you just forget it just to do it. Anyhow, so the gamma, this r was equal to, okay, no, we don't have the r. We have here, actually r, we want this length, which is r times sine of 60 degrees. So r times 6 sine of 62 degrees is negative. It's over 2. So the gamma along the weld, so this is what we are saying, that gamma along the weld is equal to minus 300, because this becomes minus 165 radian, macro radian. So this becomes that one. And the same thing again, few people address this correctly. I asked you for the normal to the weld. Some people say, okay, my writing maybe not misunderstand. You said along the weld, but the question is this. It is not E epsilon x prime and epsilon y prime. You have to select one of them and tell me whether it's x prime or it is y prime. If you are looking at this line and you are looking epsilon in that direction, epsilon in that direction is in the y prime direction. If you are looking at epsilon along that one, that is epsilon x prime. So pick up one, give me one. Don't throw that epsilon x prime, epsilon y prime, and gamma without sign, without anything. So for that reason, you may have lost another 2 points. Everybody understand that by not mentioning that. Because we are not asking you to transfer. See, the first question that you are doing here, that's how the book is, all the previous example was. Find a strain in the x prime and y prime direction. Everybody understand that. The question is what now? Read the question again. Specifically, you are at certain direction and you want to answer that question. Anyhow, those was minor, so minus 2 point there, minus 1 point there. So if you got 17, it still is very good. Yes? Okay. Everybody understand that? Yes, let's move on now. This is the type of question that you may want to take a look at it. Now we are going to go through the idea of the energy method. So what was the end of our discussion last week, last week, Thursday, last class or Thursday? What was the work of energy about, guys? Because we need to review that. Otherwise, nothing today will be understood. You see, this thing that we are talking about today and the next 2-3 classes, mathematically a little bit more complex. I want you to understand that, including this homework that I gave you, this quiz that I gave you. This quiz that I gave you is fairly simple, but you have to be very careful. We are not in ME 218 as far as more circle and in plane, out of plane, and etc. So you should be careful of how to address every question appropriately, depend what is being asked or what's not being asked. So we go to the next type of operation. Today's lecture and the next 3 lectures will be all a little bit mathematically more complex than what you have seen in the past, so you have to pay particular attention. Now, first of all, remember that what was the total energy was. I put that on this side because I need this board. So what was the total energy? So just give me 1 or 2 of them just to get started. For axial loading, this was what? This was P squared L divided by 2 EA. We put a summation here if we have more than 1 member or 2 member, like delta. Anytime you were calculating delta in an axial member, as you had several rods, you have to add deltas together. Energy is the same way. If you have several members, you have to add all the energies together, yes or no? But then this is constant. Then if it was variable, we use the integration, yes or no? For the moment, U was actually variable and constant. But the one I put in the box is more important because usually M is a function of X. So therefore, I have to use M as a function of X squared divided by 2EI dx. If it is constant, okay, in that case, this becomes similar to that. It becomes M squared L over 2EI. Is that understood? Yes or no? And for the torque was integral of 0 to L. I'm sorry. No, I don't have it. The torque usually that's constant, so I use summation of T squared L divided by 2 GJ. Now, these were energy stored. But what did I tell you at the end is very interesting. I don't know whether you recall that one or not. This is part 1 of your question. So I gave you 3 problems or 4 problems, I don't remember, for you to calculate the total energy. What's the usefulness of that? Is I call it work energy method. So these are total energy. So I repeat that for you because you may forget about it because of your quiz, etc., etc. Then this is, I call it work energy method. Yes? So what was U equal to? U equal to any? 1/2 of, remember the graph and everything, 1/2 of load. The load could be T or M or P or whatever you have. Everybody understand that? Time what? Time displacement. But that displacement, I'm not going to go through the whole thing. It has some specification with it. It must be in the direction of the load. Is that correct or not? Yes? And it has to be corresponding to that load, which means a lot. Yes or no? So in other words, this is what I meant last time. I'm repeating here. If you have one load here at point B, this is A, B, C, and you are calculating the energy in this beam, all you are calculating, if I use the work of energy method, which is the last equation. These three are the total energy. This part is result of work energy method. Notice I'm calculating only Y at B. That's it. Is that correct or not? Because corresponding to this P is a displacement under that load going downward. Yes, so I don't even get negative. I get a positive. Notice because it is in the direction of the load. Is that correct or not? Now, what is the limitation of that? If somebody comes and asks me to calculate theta C, I cannot do it. Everybody understand that. So please write it. Or somebody and ask me, come and give me the Y at D. I cannot do it with this method. This method only limited to one force and one displacement. Please write it down. It's very important. So underneath, write limited, write it down, and put it in a box because limited to only one load or one displacement. So anytime you have only one load, only one single load, which is very limited case, into the system, and you are looking for displacement under that load, then you use this method, which is, of course, as you can appreciate, is not that useful because we want to move around. Is that correct or not? Yes? Which we get to the Castigliano theory at the end of today's lecture, how to go bypass that. Now let's use these two. Now, what I want you to do, today I'm going to put some example here, some example there, or a combination of the two that you should be able to do all your homework before next Tuesday. Everybody understand that? I'm going to explain to you Castigliano method, how it works. You will be surprised how easily that can be done. It's a little bit mathematical, but I don't have time probably to give you an example. So you wait until Tuesday, but you do all your homework up to that point to appreciate the result of Castigliano method. Everybody see what I'm saying there? Because you are only 1 week and a half left. You have the final. You have one more chapter, very important chapter left. And this type of question will be in the final as well. So please pay attention. So let's go one by one. For example, look at your handout. You have every one of you have your handout. Go to problem number 1. Problem number 2 is very simple, so I'm not going to do it. So I'm going to go to problem number 1, which is this system. So it is a truss similar to there is no member here, I'm sorry. So it's a truss. Here is pin to the wall, pin to the wall. This is member 2, this is member 1. This is equal to 40 inches long. This distance from here to here is 30 inches long, which makes this member equal to 50 inches. These are all pin corrected. Member AB, member BC, and then there is a load here, P, equal to 5 kips. This is in your handout, with a slope of 4 to 3. I mean, run 4 and rise of 3. The first thing you have to decide in all of your homework, which cases. I presented to you 3 cases. First one was axial. Second one was bending. Third one was torsion. And fourth one, which was transverse shear, I said the effect of that is going to be negligible for our type of problem, not always. So we are not going to do it. Remember, I crossed the last one out. Is that correct? There were 4 cases, and we are going to follow that rule for all your homework as well, because these are the type of question that will happen. Is that correct or not? Yes? So we are going to, of course, this is everybody knows from static. The trusses are two force members, so they are force members. There will be tension or compression. If it's tension or compression, obviously it will be this case. Is that correct or not? So the question is, what is P? So the first thing you have to recognize, which I have seen people make mistake, this P is not that P. Is that correct or not? What's that P? Internal. These are the load that you will see inside the member. Therefore, you have to go through truss analysis, use either method of joint or any other method that you remember of, and find forces in every member. Sorry for that one. You thought you forgot about the trusses. You can't. Is that correct or not? Because many structure you design in future may have a truss underneath it. The body of the airplane could be a truss member going like that. Everybody see what I'm talking about. Not necessarily you can get away with it. We are talking in a truss in general. Member being connected, pin connected. Is that correct or not? Yes? Okay. So that one is very easy to do. By doing that, we are drawing a free body diagram of that joint. So let's just see it, how simply this become 4 kips going that way, because this is 4/5 and 3/5, so 3 kips going that way. And then you draw 2 forces going this way and 1 force going that way. And this force, anyhow, this is F2 and this is F1. F1 is internal force in member AB, F2 is internal force member BC, etc., etc. So F2, after you do the sigma Fx, sigma Fy, which everybody can do this here for this small joint. Sometimes you have to do, it's a larger truss, you have to do 2-3 joint to get forces in all the member. But this is only a 2-member truss, so it's very simple. This becomes minus 5K, means this member is in compression, yes or no? Because the way I draw it in tension, going away from the joint. And F1 become equal to 8K. So the force in this member is 8 kips in tension. The force in this member is 5 kips in compression. That is a job that everybody who has gone through static should be able to do it. Is that correct or not? Yes? Then comes to calculating total U. Total U for this problem, of course, is equal to U of AB, or 1, plus U of BC, or 2, yes, or 2-member. And that is equal to, you can separate it or do it at the same time, because both members have the same E, the same A. Everybody understand that. If they have the same A and A, you can put it under one denominator. Is that correct or not? But if they are different members with different material, different E, different A, you have to separate them. So let's separate them for the sake of it. So the member 1, you have 8 square times length. Length is 40 inch. Divided by 2 was the, this is not the one. That's not what I want. So divided by, okay, 1.2 inch, that's air. No, let's put the E first, because that's how that is. 10,000 KSI multiplied by 1.2 inches square, and this is KSI. So kips, this is kips, so everything works, so you can see how that happened. Go to the second one. It is minus 5 square, minus 5, become plus, of course, times the length. The length of this one, this is 30 inch, this is 40 inch. The length of this one become, of course, 50 inch. That's right. So 50 inches divided by the same denominator. You calculate that one, and the total U, after you finished calculation, it become 0.159 kip inch unit of the energy, force distance, like unit of the moment. Okay, this is part 1. So you have 3 examples like that. Calculate the total energy in this beam. Calculate total energy in this system. Calculate, this could be the torsion, bending, or axial. In this case, it's axial. Yes or no? I'm going to do one bending as well. Therefore, now this goes to the second part of an operation. You go after section 1, 2, 3 in this chapter, go to section 4. The section work is work and energy method. Now, what's this good for? To calculating the displacement at point B. So what will be the second part? So this is in second row of your homework. I don't want you to mix there. Sometimes the problem finishes here. But really, this is not useful until we get to this system. Is that correct or not? Because we are always looking for displacement, yes or no? So for this thrust, total U, which is 0.159 kips inch, kip inch, equal to what? 1/2 of, don't forget the 1/2. 1/2 because of, remember the curve that I draw for you, the total energy was the area under the curve. Since always this is the case, doesn't matter. You go P versus delta, this was the case. Everybody understand that. You go M versus theta, this is still the area, but the system changes. Because that this is for moment, everybody see that. This is for axial, and then you go for the I didn't do that, but we drove because of similarity. This is torque versus what? Torque versus phi. Is that correct or not? And that becomes this area. So that's the area we are talking about. Yes or no? Correct? 1/2 of T times phi. 1/2 of M times theta. Everybody see that? This is the theta, this is the M, this is the energy. So if I'm at this point, I want this area. This area is M theta divided by 2. Is that correct or not? That was how I drove the equation for you last time, which we end up like that. But this is why we are using it in this format. But they are corresponding to each other. Corresponding to torsion is phi. Remember phi in the torsion? Phi was TL over GJ, yes or no? Correct? Corresponding to M is theta. Corresponding to this P is delta because these are axial. We have another one for beam, which is P over Y. We get there in a minute, but you will see that. So therefore, these are the way you wrote it down. You read displacement under the load corresponding to load. I asked you to write it down last time. Is that correct or not? That's what I'm saying. Anyhow, the load here is how much? The load here is 5 kips multiplied displacement. Which displacement now? Can you define now that one? It has to be in the direction of the load. Remember that? So we are only measuring the movement of B in this direction. That's the only thing. It is under the load in the direction of the load. So delta B in that direction. So please, that's the limited. That's why it says it's limited. I ask you to write here one load, one displacement. So please write that limited to one load and one displacement only, and that displacement is specified in particular manner that you have to follow. It is under the load and in the direction of the load and corresponding to that load. Means if you have torque, you are talking about the phi. If you are having axial load, you have the delta. If you have M, you are talking about, I get to the example with that. What was the question? Yeah.
If we wanted to just know vertical, would we pick the 3 kips?
We'll get to that because that's the Castigliano, everybody. However, geometrically now we can calculate that. Let's calculate delta B, then I'll tell you what happened. So if you calculate this delta B, so delta B become equal to, you just multiply that by 2 divided by 5. Delta B in that direction become 0.0635 inches. So in other words, what you are measuring here, because this member is under compression, so this will come to here. So like that, so this become under the tension, something like that. So this one become like that. So you are measuring this distance, this point coming from there in that direction. Now approximately you can calculate the vertical displacement and the horizontal displacement by geometry. Everybody understand, because that is given the direction. Is that correct? However, there is another method to do directly those displacement, and that's with Castigliano method. We'll get to that. Is that this is in the direction of the load. Is that understood? Yes? And it doesn't come negative or positive. It means because the load was in this direction, the answer, if the load was in that direction, it would be in that direction. Is that correct? Yes? Okay? Correct?
Yeah.
So we calculate that. Now let's go to the second problem. The second problem is a little bit, I have to do that because a couple of people came to me and said we want to do a beam analysis. I said just wait until I do it because it is a little bit information needed to pass to you in order to do a least amount of math. Now, this was case 1. Now I'm going to case 2. Case 3 is very simple because case 3 is like case 1. Everybody understand that. Therefore, I'm not going to do problem number 2. Look at problem number 2 in your handout. What should I do there if problem number 2? I can calculate total energy of AB and total energy of BC, but I cannot calculate delta at C and delta of B because there is more than one load there. Everybody understand that. There's 2 loads there. Therefore, it has to be limited. This is what I'm saying, guys. If you have a problem like this, only one load here, you can calculate U stored in AB, which is very simple. It's axial, plus U stored in BC, which I did much more difficult than that. Yes or no? Then you put U equal to 1/2 of P times what? Delta at C, because that's the direction of the load. Is that correct or not? However, if I have 2 loads there, I cannot do it because this system is no longer valid. How do we get around it will be at the end of today's lecture. Everybody understand that, which I have more than one load. Because look what I wrote here, limited to 1 load and 1 displacement. So if you look at all your homework in the first row and second row, you will see there is only 1 load and 1 displacement, which is limited cases. But it shows you how to formulate the problem until we get to the next theory. So this one is a beam now. This is the same under the same scenario, and here is the beam. Here, let's say it is a roller. Here is a pin, and here we have 6 kips load here, and let's call this one beam AB and BC. Obviously, this is not axial member. This is a bending member. Can I use the constant formula or it is a variable? Everybody in this class, after we went 2-3 weeks on the beams, superposition method, I don't know, singularity method, direct method, double integration method, I have no doubt that everybody knows that M is a function of X. That's first part. The second part, M at AB is different from M than BC. Agreed or not? Because there is a load here. Yes or no? Yes, sir. There is a load here. There is a reaction here. There is a reaction here. So M could be something like that. Go up and down or like this. Is that correct or not? Yes? Therefore, 2 functions. It cannot be expressed as 1 function. Yes or no? Therefore, when I want to use work and energy method, first of all, if I want, let's go to total energy first. The total energy in this system, let's give me the length, first of all. Let's say this is 12 feet and this is 6 feet long, which is a fairly long beam. And we want to calculate first the total energy. So that's the question we want to answer. And if I want to use work and energy, again, what can I calculate in this beam? Deflection at C. That's the only thing I can calculate. Everybody understand this beam is going to go like this. Everybody see that? I only are able with this method to calculate the Y at C. I cannot calculate Y here. I cannot calculate theta there. I cannot calculate theta there. I cannot calculate theta there. Is that correct or not? Not yet.
So just to make sure, we can only calculate the displacement at the point that the load is.
Under the load.
Yeah,
You wrote it like that. Read it, what I asked you to write. That's the whole thing. Between Thursday and now, you forgot what you have written in your notes. It was under the load corresponding to that load. It has to be under the load. Absolutely, you are correct. Mm-hmm. You understand what I'm saying there? It has to be, otherwise it doesn't. I didn't go through the theory in detail, but that was the result of the theory. Is that understood? Yes? Mm-hmm. But the displacement is along the load. Actually, exactly look at the first problem. Must be under the load, in the direction of the load, I said, and corresponding. Corresponding here, corresponding to this is y. If the same beam I put here, MO, what am I measuring? What can I measure there? Theta. That's what I draw those little curves there. Corresponding displacement according to the loading. So we have three systems. We have M versus theta. We have, for this beam, we have P versus Y. For axial member, we have P versus delta, yes or no? And then for the torque, of course, we have torque versus what? Versus phi, which is the angular. I gave that in the table to you, so I don't have to repeat it. In the table, I gave you all the deformation, relative deformation, correct?
Yeah.
Good. So I want to make this clear for everybody. I know that you are clear about that, because sometimes this is misunderstood. However, now we want to do that. First things first. First, we have to calculate the reaction. So reaction, you can take the moment about here or there. So the moment become, the reaction becomes, this is A, so this one becomes 3 kips going down, because this one was to go up, and you have to bring it down. This one will be pressed down, so the reaction is upward. So that is 9 kips. After you take, as you see, it's balanced. So that is your reaction, which is the static part of it. Then comes to U. If I want to calculate U, let's put back B here. This is DC, A there. So we choose this as XY system of coordinate, correct? Yes. Then we have to write U equal to. Now, this is a decision you have to make. And if you don't make this, that means you never were listening to the previous lecture. U has to be 2 parts, AB and BC. U of AB plus U of, why we are saying that? Because M is a different function as you learned it previously. M is a different function from A to B than B, so it cannot be expressed under, because one line is going like that, the other line is going that way. Is that correct or not? Yes? However, for the first part, it's very simple. U of AB, let's calculate U of AB. In order to calculate U of B, it is 0 to what? 0 to 12. That's the length of the beam, correct? Look at the formula there. M, what is M now equal to? Now here, in the other class, there were few people who still misunderstand this M as a function of X. But by now, in this class, after we went through so many different versions of the beam, everybody should be clear what the M is as a function of X. If you cut it here, and you call this distance X, this should not give you any headache. Everybody should write. Actually, it's 3X. Is that correct or not? Yes? But the point is that plus or minus? How about minus? Yes? Look, the action is plus the reaction is, because you are talking about internal, not external. Right? When you say plus, it is still external. You understand that? When you reverse it, it is internal. Yes or no? Still have people problem there. But this, write it down. For M, for section AB, or for AB, M as a function of X is minus 3X. But the beauty of that is that, anyway, if you make a mistake, doesn't matter, because minus square and plus square is the same. But that doesn't mean you should be wrong. Everybody understand what I'm saying. That's exactly my point. When I subtract points from you and you guys get upset and say, why did you subtract? That's where I'm referring to, if that understood. Sometimes it's not a clear case. The moment there, if you want to plot it, the action is positive, the reaction is negative. Is that correct or not? Yes? However, anyhow, so goes there, become minus 3x square, is that correct? Divided by 2EI, EI is constant, times dx, which of course 3 become 9 divided by 2EI, integral of x squared dx. Of course, everybody knows that this become x3 over 3, no, x3 over 3, and then you put the 12 and 0. 0 doesn't have any effect, so you calculate that one. And the second part, now, the calculating the u, so I'm going to put both of them together. This is part 1. Now, UBC. How do we calculate UBC? I need the m again as a function of x. Yes or no? Notice in previous chapter, I was insisting that you should use the same xy, yes or no. It was simpler because I wanted to put here theta 1 equal to theta 2, y1 equal to y2, yes or no? Which some of you didn't want to follow, yes? You wanted to go to the other side, yes? Here it's totally in reverse. You don't want to use the same x and y axis. This is not the previous chapter. Now, what happened here? If I want to write m here as a function of x here, I have many terms here. Everybody understand what I get? I get 3 times x plus 9 times x minus 12. Is that correct or not? Then I have to square that to get the m, but then m becomes squared. The integration is over x. Is that correct or not? Who cares m, which way I calculate the m? Because I don't want to use theta 1 equal to theta 2, y1. All I need is the magnitude of energy. So instead of going from the left, isn't that better to go this way? Yes or no? Yes or no? Which m become equal to what? M become equal to 6 times x or new x, whatever you want to call it. Some book call it d or something else, or x prime or x1. Everybody understand that. So depend on the book. Some book call it the same x. I rather call it the same x. I want to show that everybody see that for part 2, I'm going this way. Now, what's the advantage? I'm going to write both of them for you to see. If I go this way, UBC become, which is not good. UBC, first of all, when I go from B to C, I have to go from 12 to 18. So that is 12 to 18. Then I have 3 times x like before. I have minus 3x plus 9 times x minus 12. The whole thing to the power of 12, 2 to the power of 2 ei dx. If I keep the same x and y, look how many terms you have there. And you have to square it. And worse than that, you have to go from 12 to 18. All of that become equivalent to, because the m is m. I don't care whether I go this way or I go that way. Is that correct? The 2m are equal and opposite. So I go from the right, because this is not previous chapter. What chapter were that? I forgot. Chapter 8, 6, or whatever it was. 7, 8, 8, chapter 8, 9, chapter 9. Yeah, it was chapter 9. So in chapter 9, we were dealing with the deformation of the beam singularity method. The other method, we always use 1x and y in general. Here we go, not even that. Look the advantage. We go from C to B, from 0 to 6. Is that correct or not? Yes? Because this is new x. This has nothing to do with the old x. Is that correct or not? 0x. And the action, look, the action is positive. The reaction is negative, so minus 6x to the power of 2 divided by 2ei. So bottom line is this. Change your x coordinate as many times you want to get the minimum amount of term, because that is the system. Is that correct or not? Yes? There, definitely you should change. Actually, this is a must. Otherwise, you get into lots of math for nothing, because you spend half an hour extra time doing lots of math. Change, put your x and y at A, at B, at C, wherever you find that the minimum amount of term is, because you are not calculating the m, you are calculating the energy. Is that correct or not? Anyhow, you simplify these two. Again, this becomes 36 divided by 2. This becomes x squared, like the other one becomes x3 over 3. And the total energy, when you add that, when you add the u of AB to u of BC, the result becomes this number. So I want you to, it's very simple. You just multiply through it. It's really not that difficult. And it becomes 3,888 divided by EI. Now, what I did not give you is the value of E and I. Sometimes we leave it at that. If EI is not given, we leave it with that. Is that correct or not? Notice there is no sign there, because that's the total energy. It's always positive. And then let's calculate for this problem. Let's say that E is given equal to 29,000. I believe I used towards that. Yes, KSI. And let's say I is given equal to 120 inch to the power of 4. Now, if I put here, notice I did not go change this 12 foot to the inches, this 3,000. Some of you are used to do that. That's a no-no. If you put this 3,000 here and put 12 into inches, becomes 72. Your math become much. I mean, it is sort of, you can never finish that. So notice I use the same data as is given. I make the adjustment like before at the end. What's the unit of energy? It should be kips. It should be force time distance. Yes or no? Correct? What are we using? Kips and inches or foot. Is that correct or not? Now let's see what we have here. If I want the answer to be kips, inch, this is what you said. Okay, let's stick to that. That's what I want to end up. Now, let's put E here. E here, 29,000 what? What's the unit? Kips per inch square. Multiplied by 120 inch to the power of 4. We went over this before, if you recall. The unit of EI is always load kips times inch square, the way it's given. Yes or no? Because this inch square and inch square. What do you think the unit of this is now? In order to end up in kips inch, what the unit will be equal to? It will be kips to the power of 2 because you want one of them left. Is that correct? Because one of them drops out. So this one has the unit of kips to the power of 2 because if this and this drops out, we end up with 1 kip. Is that correct or not? Then what should I put here? This is inch to the power of 2. This will be foot to the power of 3. That's right. Because if this is foot to the power of 3, so this must be it. Because I end up with 1 force unit and 1 length unit. Everybody see what I'm talking about? Yes or no? However, if I multiply this 3,888 by 12 to the power of 3, all my feet become into inch, yes or no? So it becomes inch to the power of 3, and then 2 of them and 2 of them drops out, 1 kips and 1 kips, so you end up with kips inch. So that's it. That all you have to do this, and this ends up by this is everything, it's taken into account. You become equal to 1.93 kips inch or 1,930 pound inch if that's what you want, but that's good enough. Okay, correct? This is total energy. What are we calculating if we go to the work energy method? We are calculating displacement at C. Yes or no? Absolutely. So you say U, which is, this is work energy. Write it down in your work energy method, which are the second and third line of your homework. Were equal to 1/2 because of area under the line, 1/2 of the load, which is P. P is how much? 6 kips, correct? Multiplied by Y under the C, because we know how much C going down. Is that correct or not? Yes? Displacement under C, which all the other method that we talk about it in previous chapter, all of them also applicable. So really, this is not for this type of problem, because this problem can be done easily with superposition method. Everybody understand that? Easily with double integration or its other method. This method, I show you this to get to the next problem, next 2 problem, actually, which is much more interesting. Nevertheless, YC, this is just for you to get warm up. Everybody understand that? Now, the next 2 problems shows you the advantage of this method, which is for special problem. Everybody, because in other words, who cares about this method? It's much more fancier than the previous method, especially the superposition method. Is that correct or not? Yes? So YC become, here, calculate the YC. YC become 0.643 inches, because this is in kips inch. Remember, this was in kips inch. YC equal to, what did we have? 1.93 kips inch. Kips and kips drops out, so YC become in terms of inch. V1, that's why I've changed the foot to the inch. Now, the next problem is the one that you will see most likely in future courses. You are going to see more of this energy method in your next course, which is a stress analysis course. Then you are going to see probably I have seen previously, Dr. Anderson showed me a couple of his homework problem. When you go to the machine design and you have to do special pieces, which is not like a beam, and you want to calculate the displacement or find out what's going on there, then you use this energy method. So it's more advanced classes. In a standard beam or a standard trusses are not your cup of tea. Everybody understand what I'm saying? That is that correct? Or if it is, there are much simpler method than energy method. Now let's use one of this problem. That's the only time I have. The other problem is in your handout, problem number 3, which is in your book as well. But this is the one I'm interested for you to solve. So here we go. This is a piece of metal cut like this, part of your machine design. And you are putting a force P here. And of course, you are using work of energy method because this is the only method that actually works here. Remember that. There are some other method, more advanced method, but from what you have learned so far, maybe the energy method is the best method to calculate the displacement under the load. Is that correct or not? So if this thing is going to bend like that, it's going to bend, it's going down, you are calculating how much point C is going to go down. That's the point here. So let's assume this is the thickness is the same, E is the same, A is the same, everything is the same. Let's say the length here is 2L, center to center, and the length here from center to center, from end to the center is also L. Is that correct or not? How do you solve this problem? Of course, again, this is, like before, it is rod AB and rod BC. You have to handle it like that. If you have a frame like this, by the way, you have to go AB, BC, and CD. This is for that kind of problem, but we don't go that far because that's basically for civil engineering design. You have a frame, you can design a frame. Actually, with this method, you can design a frame like that. Everybody see that. So you put the rod here on the here, and this is on a ruler, and find out how much that moves. Is that correct or not? That sort of thing. But let's not go that far. But nevertheless, here is the scenario. The question is this. First, again, calculate the total U. And then, of course, if I'm using work energy method, what is displacement? Because I cannot call it delta. Displacement under the load, how much is going to go down? Yes or no? Correct? All right, that's the question. Then, again, we have to write it like that. U equal to U of AB plus U of BC. Everybody appreciate from a static point of view, this section and this section behave differently. Is that correct? As soon as they are behave differently, I have to go to different system. That's all I'm asking you to do. Is that correct or not? Which means first you have to understand the static of the problem. Correct? So let's do BC is simpler. Let's do BC first. So how do I calculate length BC? You see, this is BC. I cut it here. Yes or no? Yes? Correct? So there is a load here, P. What do you have at this end, statically? That's a very simple question to answer. Do you have a normal force there? Normal force. Normal force is not that one, guys. This is normal force. Normal is perpendicular to the cross section. Yes or no? Do you see what I'm talking about? Still, if you consider this normal force, we are in trouble. All of us, including me. Is that correct? A normal force is perpendicular to the cross section. Is any there? No. So that is not there. Is there a shear force there? Yes, because this P creates here a shear force equal to P. Is that correct or not? Yes? Is there, this is it, or do I have a bending there? Of course, a bending there. So PL goes like that, and then reaction to that, this is M equal to PL. Is that correct or not? Because the length is L, correct? Now, notice I can put again my X and Y here, or I can put my X and Y there. Where do you want to put it? Right or left? That's right or left. Whether you are behind the board or in front of the board makes a difference. Is that correct or not? Yes, from which way? So anyhow, do you want this one or that one? Let's put it this way. This one, yes? Yes. Because if I cut it here and call this X, I have to write P times X plus or minus, then M become 2 term, which is PL. From here, I have only one term. Everybody understand what I'm saying that? So this one, whether you want to call it right or you call it left, so I call it from right to left. Is that correct or not? That's what you meant? Yes? Okay. Correct or not? So what's the moment then? P times what? So this is not your X. By using this, not this one, this is your X. Is that correct or not? Yes? So therefore, it is P times X. Again, this is plus, and that is minus. So MX become equal to minus PX. Again, minus doesn't matter because it's square. Is that correct or not? Yes? You can put Y downward or Y upward, but that's the right answer. Is that correct or not? Therefore, U of BC, or in this case CB, because we are starting from C going to the B. Is that correct or not? Is integral of 0 to L, correct? So that's the length. M square, look at it. What's M square? Minus PX square divided by 2EI dx, correct? Everybody can do that. That becomes P square comes out. This again becomes X square. Integral of X square is X3 over 3. Minus become plus. So you simplify that. That becomes equal to P square divided by 2EI times L3 over 3, because X3 over 3, because 0 to L, L3 over, or it becomes equal to P square L3 divided by 6EI. Yes?
Wouldn't the reaction be positive px for
What?
the reaction would be positive px for the moment equation?
This one? Are you talking about this one?
No, for your moment equation.
This one?
Yeah.
The action is this way, which is?
Negative.
No, that way is positive.
Clockwise is negative. And the reaction.
Not, my friend. I cannot get this to you guys. No, 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 no. No, 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 no. You are still living in a static class or whatever you are, wherever you are. Look, this is what? Plus or minus? For deformation wise. What do you think this is? Plus or minus? Plus. That's what I said. Exactly. So this, look. This is plus, this is plus. This action is plus, goes that way, is this way. Yes or no? It's plus. Therefore, I want that way, which is this way, and that way. Therefore, it is negative. Agreed? We are internal, not external, for the last time. Yes or no? You are not going by static. You are going by smiley face and frowny face. Yes or no? How many times do I tell you? This is a combination. This is like tension and compression. Yes, that's exactly what I asked you. For some of you, don't go this way, because I was afraid about this question. You see that? Yes, because the sign changes. The same thing with the shear. Guys, this is positive. This one is positive, because they are equal and otherwise one cannot be positive, the other side become negative. That's a no-no. Yes or no? That's what you are talking about. Again, okay. Anyhow, that changes that. I know that still, no matter how many times I explain it to you, you have to be careful about what you are doing in ME 218 versus 219 versus the static. Is that understood? This, we are talking about this system being positive and this system being negative. So anyhow. So nevertheless, this is correct. So that's UCB. Is that correct or not? Then we have to go now to part AB. That was, I thought, that's much simpler problem. In part AB, now what do we have? Now here is again a scenario. What should I put there? This force goes equal and opposite, which I put it here at the center. It becomes like a axial force. Yes or no? Because that's when you pull this one down, that's going to stretch. Is that correct or not? So that is the static of the problem. Equal and opposite to that. Yes or no? This one is counterclockwise, so I should put here clockwise. Yes or no? M equal to PL. This is equal and opposite because you cut it at that point. On one side, whatever you decided on one side, on the other side become equal and opposite. Now, what is this member on there, Mr. Nazarian? What is this member on there? Is it a variable moment? Yes, it is is it a variable moment or a constant moment? It is a constant. As far as this is concerned, M, that's exactly what you want you to be paid. This problem is very good. M is constant. The other one is what? The other one is axial, which is part 1 and part 2. You have one part 2. So U, I'm writing that. U of AB become equal to axial, which is P squared, because the load is P, yes or no? But don't forget, the length is 2L, because we are expressing everything in terms of PL and EI. So you have to be careful for this kind of problem when there is a now number is given. So if this was given, for example, 3 feet, this would have been given 6 feet, or it would be no problem. But when I give it this way, people sometimes they make mistake. These are symbolic. This is force square, length square. Yes, so force is P. If this force was 2P, you should have put here 2P. Is that correct or not? Everybody understand it? The force square, which is P square, the length, which is 2L, is that correct or not? The length of the rod right now is 2L, not L. Is that correct or not? Yes? Divided by 2EA. 2EA. Which this 2 and this 2 drops out, so become P squared L over here, which is due the energy due to the internal axial load. Is that correct or not? Then plus what? Bending, but bending I do not need to integrate because bending is a constant. Remember what the constant was? The constant was because this all comes out, become dx become x, L become M. So become M squared, L time become like the other one. Is that correct or not? Yes? So therefore become plus, no integration needed. M, which is PL, so it's PL squared. Is that correct or not? Yes? Multiplied by length of the rod, which is 2L, again, don't forget that. Divided by 2EI, because this is the bending. This is axial, 2EA, this is bending, and then you add this part and that part together. So this becomes simply P squared L divided by EA plus 2 and 2 drops out. This becomes similar to that one. This becomes P squared L3, because otherwise, if it's not L3, it's not. See, if you end up here L2 and there L4, something is wrong. Everybody understand? It has to be the same format because both are bending. So you add the two together. This is U of AB. The other one was U of CB. So you add this to this together. Total U become equal to P squared L over EA. Here you have 6 over 6. Here you have 1 over 6 because the rest is the same. 6 over 6, 1 over 6. So it becomes 7 over 6. So combining together. So 7 over 6 of P squared L cubic divided by EI. This is the question number 1. Total energy stored in this picture. Now, what's the usefulness again? Using the workout energy method. So this total energy equal to what? So I write that in color. Equal to what? This is workup energy. Equal to 1/2 times what? Load, which is P. Exactly. Times what? Displacement on that. In other words, this beam in exaggeration format, this is going to stretch and bend. The stretching is due to that, bending due to that. This rod is going to, this is in exaggeration. It's going to bend, and you are calculating this, let's call it delta C. This is in very exaggeration form. Is that correct or not? So you are calculating the delta, which is very useful for mechanical engineering design. Remember that this does not follow the routine beam and column action. Is that correct or not? Yes? So anytime you have an odd shape, many times they will give you in the design classes, in the machine design classes, you will get a few of this problem. You have to find a way to solve it. one of the way look into this. Is that correct or not? Yes? Okay, when you get there, of course. Times what? Times delta C. Vertical delta. That means it should be going like that. No sign attached to it. In the direction of the load, under the load, in the direction load, and corresponding to that load, which is vertical displacement. Anyhow, delta C become equal to one of these P drops out. So it become equal to 1/2 actually drops out. So you can calculate that. That's no problem there. So I don't know whether I have that one here or somewhere. So yeah, okay. Del YC become 2PL over EA, which is very interesting. If you have a rod here and you put a P here, what's the displacement under this load? This one? How much going down? PL over EA. But if this is 2L, so it becomes P times 2L over EA. Yes or no? Look, P times 2L over EA. That's coming the same. Is that correct or not? Yes? The rest is due to the bending of this one and the other one. Everybody, but this rod is going to be stretched and bend and bend. Is that correct? Half of bending come here, the other part is here, one part there. You don't see all of that, but it came to the picture. 7 times 6, it become equal to 7 over 3 PL cubic over EI. This format was in your system there. Okay. Correct? Okay. Now, for the other class, I had about 10 minutes to go through the idea of the Castigliano method. I'm a little bit behind. We need to finish it. Otherwise, we cannot go. So please give me 5 extra minutes. And we are going to at least explain to you what is the Castigliano and establish some criteria there. And then we go home. Hopefully, so you will. Because otherwise, I don't want to fall behind. Now, what was the restriction here? Notice one load and one. If it becomes 2 load, the system confuses itself because I don't know to calculate displacement under which load. I explained that earlier. So let me erase the board and tell you what happened there quickly. So at least, and then next time, hopefully. Now, by saying all of this example that I did, you should be able to do at least 8 of your 9-12 problem, which is energy method and the work on energy. But you cannot yet do the Castigliano. First of all, I haven't done any example. You should not actually start because it is a little bit complicated. But the idea is this. If I have more than one load, which I want you to look like this. So I put here a P and I look MO. So if I use the total energy, which I can calculate the total energy, am I calculating theta at that point A? Or am I calculating A? I cannot answer. Is that correct? Or because the two combined energy will give me, let's say this is point A, this is point B. But what I want you to do, go to your note. Everybody has a copy of the appendix A, which shows you superposition method. Go to the superposition method. Give me delta A and YA by superposition method, which is case 1 and case 3. Please, everybody. Go to that handout that I gave you a long time ago and give me theta A and YA of that beam. I hope I can find it. Yeah, here it is. All right. Did you find it? Case 1 and case 3. Anybody can give me the theta for M? What was theta for M here? Come on, guys. MOL divided by EI, correct. Plus or minus? Minus. Fine. Okay, great. What is theta for the P? Because I have to add. Remember, we break this into 2 parts. 1 P, 1 M, and then add it together. Yes or no? In superposition method. This is a very simple superposition method. Yes, and then what will be there for the P? PL minus, first of all, it's going down. PL cubic divided by 3, similar to the answer we got here. Look, PL, everybody understand. This is the different number because it's different system. Is that correct? This number has changed. Notice this. This exactly is there. Is that correct or not?
That's for Y.
Oh, that's for Y. That's right. Thank you. I'm rushing it. Correct? That's for theta. Yes? And let's calculate the y the same way. Y at A become minus MO L cubic divided by 2EI. Is that correct or not? For M, yes? Plus minus P L cubic divided by 3EI, which is for Y. Yes, so from the table, which is case 1 and case 3 in the table superposition. The one I didn't give you a quiz. Yes or no? Yes? I gave you the singularity. But now, what?
It's 6, it should be 6.
6? Are you sure?
Just going by integration.
No, this PL cubic, I have 3EI. No, you're wrong. This is for P. It's not for uniform load. I think it's correct. I think it's correct. Yes? It's correct. All right.
Is there a reason why it's not 6? Because when you integrate the 2 doesn't.
What?
I'm just curious.
No, the length is L. No, this is for length L. This is what was given in the table. PL cubic divided by 3I. That's what something else. This was nothing. This was combination of, yeah, this is different. Is that correct or not? Yes?
You can see it if you look at the.
Yeah, no,
it
I
is a
know.
six.
Correct?
We got it.
All right. All right. Okay. Now, because that's the energy. This is 1/2. There is 2 added here, 2 added. So that is my friend. That was 2 times 3. Okay. So that these 2 and these 2 should go. That's why you are looking there. You think it should be 6. Is that what you are looking? No, actually it is 2.
Okay.
There is a 2 there, extra 2. Yes.
Yeah.
That answers your question. Very good thinking. As he saw here 6. Then I thought this should be 6. This is what he was thinking. I like that. Is that everybody understand? However, there is a 2 added to that for you. Is that correct? So actually it is 2. This comes out. This 2 and that 2 comes out. It becomes like that. Is that correct? That's what my answer. Anyway, I knew what you were asking when you were debating. Anyhow, let's not do that. Otherwise, I have to keep you a little bit longer. This is by superposition. Now, can I separate these 2 from each other and use energy method? Yes or no? Yes? I used it for superposition. Why? Because everything was linear. P, P, M, M. Can I use it for energy? Yes or no? Absolutely not. Again, you are always wrong. I don't know why. You end up always on the wrong side of the thing. I don't. If that was the case, why I'm asking you? So I'll go ahead and use it. Is that correct? Just be smart. Is that correct or not? Yes. Look what happened, guys. If I use one single one, the energy become px. Yes or no? I mean, the moment become px. Yes or no? And this one, the m become m because it's constant. Yes or no? So then the total become px square plus m square or minus m square. Yes or no? Now, if there are 2 together, the moment is here is equal to what? The moment there is p times x, correct or not? Plus or minus m square. Is this the same as that one? No. Therefore, I cannot use the superposition method, and I told you why. Because the energy is not linear. The energy is square. Everybody understand that? If I use that, this becomes this square, this becomes this square, but I have 2 times this time that. For that, you can refer to your book. That's a Maxwell theory that shows you how these 2 affect each other. So if you apply the first one, there is some energy transfer to the second one. From second one, energy transfer. Good luck for reading that. There's 2 pages of heavy math. Everybody understands. But read it if you want to, but that's the result of that. That's Maxwell theory. Everybody understand that. So what I'm bypassing that. All I am saying that, write down in your note. The system of superposition does not work. Therefore, I have to put them together. I cannot separate them from each other. So still my beam is like that. And this is my P. So let me finish that one. That is our M. So here is your distance x. So your mx, again, this px become positive. the reverse of that become minus px, p times x. The moment is the way I have drawn it, is positive. So the reaction minus mo. So that is my mx. Yes or no? Correct? Then my total u become integral of 0 to L m squared, which is minus, I can write that like that, minus px plus mo. I can bring them minus o. And then minus squared become plus. So it become px plus mo squared divided by 2ei dx. Is that correct or not? Notice you get 3 terms. If you were separate from each other, you get only 2 terms. Is that correct or not? You get one square plus the other square, not combination of the two, which is the result of Maxwell theory, but we are not going through that. But here you get px squared, mo squared, plus 2mopl. Everybody under px there. Then you have to integrate all of that, which I leave it up to you. So let's just simplify that. That become 2ei here. This become p squared x squared plus mo squared plus 2mo px. All of them dx. In other words, all the x that you see here become, this x become x3 over 3. Here you get an x. This x become x2 over 2, which everybody can do that. And then finally, you end up to this system. I give you the result. It's very simple operation. You integrate over x, so you get the following formula. You get p squared L cubic divided by 6ei. Again, that 2 is there. That my friend, you said that. That's the same. P squared x3 over 6ei, x over 3, plus mo square L, because you get x here, divided by 2ei plus 2 and 2 drops out. You get mo L squared, because this 2x become x squared. So divided by 2ei. P, no, there is a p there as well. P mo 2x squared. That's right. That's your total energy disturbed. Now, this is the result of Castigliano theory. I'm not going through that, but I'll give you this. Now assume P is variable. Calculate the partial derivative of u with respect to P. Partial derivative of this energy with respect to P. So what you get? As if P is your variable, not x. So what is the derivative of p squared? Is 2p. 2p, nothing else. Is that correct or not? So it becomes equal to 2p L cubic divided by 6ei. Then what's the derivative of that? Is there any p here? No. So that derivative of that becomes equal to 0. And the last one, derivative with respect to p. There is one p here. So the whole thing, is that correct or not? So derivative of this p is 1. So please press mo L squared divided by 2ei. Do you see that there? What is this? Is this the theta A or ya? Exactly.
That's why negative y.
No, because this is in the direction of the load. Remember, there is no sign in this method. Yes or no? Because the load is downward, the displacement is downward. So there is no minus, absolute. But is this why? Here, did you see what happened there? So write it down. The derivative of u with respect to p gives you the displacement under the load. Is that correct? So the derivative, now tell me this without me telling you. Derivative of u with respect to m, what does it give me? Will give you theta. Is that correct or not? Look how interesting. You express your u as a function of your load. You use your load, and then you take the derivative of u with respect to that load as if it's a variable. You get the displacement. For any load, number of load, doesn't matter. 1 load, 2 load, 10 load. Everybody understand that. So du by dm. Now this time m is your variable. Does this have any m? No, it become 0. This one become 2m. So it become 2mo L divided by 2ei. 2 and 2 drops out. And the last one become what? The last one become P L squared divided by 2 EI. Exactly this is your theta A, and this is your YA. So I will explain that, the application of this Castigliano method in your problems. You can have 5 load, 10 load, you have any load. You take your U as a function of the load, and then you take the